All right, guys, so we made it. This is the last part of Chapter 1. So this will be the last lesson in Chapter 1.7. We might do some review stuff on Friday. We'll see. But this is the last part of Chapter 1.7 and Chapter 1. So what we're looking at some common formulas. So temperature, F is Fahrenheit, degrees in Fahrenheit, C is degrees in Celsius. So Celsius is equal to 5/9 times Fahrenheit minus 32. We also have simple interest. I is interest, P is principal, R is our annual interest rate in decimal form, and T is time. So our principal is kind of what we put in, or what we're starting with, and I is kind of how much interest we earned. Distance, D, is distance traveled, R is rate, and T is time. So we'll be kind of manipulating these formulas today and using these formulas here. So our first one is solve the formula for F, for our degrees in Fahrenheit. So we have this here. So Celsius is equal to 5/9 times F minus 32. Now normally we would divide by 5/9, but what I'm going to do is multiply by 9/5. Multiply by 9/5. And what that works out is these cancel. So multiplying by the inverse, or not the inverse, the reciprocal, the flip of that fraction will cancel them out. Now the reason I did that is because I want 9/5 times our degrees Celsius is equal to Fahrenheit minus 32. So that's kind of might not be an intuitive step for y'all, but that is one thing we can do. So we have that there. So we're getting closer to get Fahrenheit by itself because that's what our goal is. Now what we want to do next is we want to get F by itself, so we're going to add 32 because that will get the negative 32 to cancel out. And what we're left with is Fahrenheit is equal to 9/5 times whatever the Celsius degree is plus 32. And that right there really is the formula for finding Fahrenheit when they are given a temperature in Celsius. And we might need that because here they told us two things. Which temperature is greater, Mercury or Venus? So they gave us Mercury in degrees Celsius and they gave Venus in degrees Fahrenheit. So we have a formula now that will convert Celsius to Fahrenheit. And for me to use it, what I need to do is I need to plug in the Celsius temperature in for C. So the Celsius temperature is 427. So what we can do in a calculator is we can do 9/5 times 427 plus 32. So you can go on and grab your calculator. And if you plug that in to the calculator, you will see that this here should give us 800.6 degrees Fahrenheit. So how hot is Mercury? It is 800.6 degrees Fahrenheit. Now we could have used the other formula, 5/9 times Fahrenheit minus 32. So 5/9 times, so our Fahrenheit for the other one was 864 minus 32. And again, if we want to solve it this way, we can plug it into the calculator. So type in 5/9, parentheses, 634 minus 32. And if we plug this into the calculator, we would get 462.2 repeated for Celsius. So, which one's hotter? Venus has the hottest surface temperature because it had the greater value. And that's it. That's all we had to do for this here. So we'll do the same thing here. So we have our formula. On a July day, the temperature at the peak of Mount Everest is negative 16 degrees Celsius. Is that temperature warmer or colder than 0 degrees Fahrenheit? So Let's just assume we don't know what freezing is in, well, freezing for Fahrenheit is 32 degrees. 0 degrees Celsius is freezing. So we kind of have a gauge there. So we'll see, is it warmer or colder than 0 degrees? So to find that out, what we're going to do is we're going to replace C with negative 16 to find out what 0 degrees or 16 degrees Celsius, negative 16 degrees Celsius is in Fahrenheit. So I have 9/5 times negative 16 plus 32. And again, at this point here, I would just plug it all into a calculator. You don't have to do this by hand. There's nothing that says that you have to. And if we plug this all in, we get 3.2 degrees Fahrenheit. So this here would be what? Warmer. It's warmer than 0 degrees Fahrenheit. So 0 degrees Fahrenheit, so negative 16 degrees Celsius is warmer than 0 degrees Fahrenheit because it has a higher temperature than 0 when we plug it in and convert it back over from Celsius to Fahrenheit. And that's all we have to do for this one here. So we're going to deal one more with temperature. A fever is generally considered to be a body temperature greater than 100 degrees Fahrenheit, or like the thermometer say, everybody is 97.5 or 97.3. Ha ha ha. But your friend has a temperature of 37 degrees Celsius. Does your friend have a fever? So again, we're going to use this formula here and plug in 37 degrees for C and simplify. So at this point here, again, you can pull out your handy dandy calculator, do 9/5 times 37 plus 32. And it'll tell us that your friend has a temperature of 98.6 degrees Fahrenheit. So do they have a fever? No. Unfortunately, or fortunately, depending on how you sit, they do not have a fever. Because it'd be about 37.8 degrees Celsius would be a fever. So if they had a temperature of 0.8 higher on the Celsius, so 37.8, they would have a fever. So they're close, but they don't have a fever. And that's it. That's all we've got to do for these here. Now we're going to look at some using simple interest. I equals P RT, where P is our principal, R is our rate, and T is time in years. So if we look back at our thing, T is time in years, principal, our rate is in as always as a decimal, and principal is our what we put in. So now let's look at the problem. You deposit $5,000 in an account that earns simple interest. After 6 months, the account is earned $162.50. What is the annual interest rate? So let's plug in what we know. So we know that the interest earned is 162.5. That's our I. That's our interest that we earned. Our principal, what we started with, is 5,000, so we'll plug that in for P. Now, we don't know what the rate is, but we know the time is 6 months. Now, again, time is in years. So how many years, how many months in a year? There are 12. So 6 divided by 12 is 1/2. So we have to write it in years. So 6 months is half a year, so we have 1/2. We have to keep it in terms of years, not months. So we have this here. Now what are we going to do? We're going to solve for the value of R. So let's simplify this side. So 162.5 won't change. But I can do 5,000 times 1/2. We can plug that in a calculator. We can type in 5,000 times 1/2. And if you type that into a calculator, you should get 2,500 R. 2,500 times R. Now, again, what are we solving for? We're solving for R. So the first thing we did is we kind of simplified the right side, and we got 2500 R. Well, I just want to know what R is, so to get R by itself, we're going to divide both sides by 2500. And when we do that, 2500 and 2500 will simplify to just R. And now we can plug this here into the calculator. So you can pull your calculator up and do 162.5 divided by 2500. And what it'll tell us is it's 0.065. So our interest rate is 0.065 or 6.5%. So we have earning 6.5% interest on this account, which is pretty good. That's a very good interest rate. Because normally if you can get an interest rate on a bank account for 2% or 3%, that's doing well. 6% is amazing. But that's it. That's all we have to do for this year. So here you deposit $3,500 in an account that earns 4% simple interest. How long will you have to leave the money in the account to earn $3,500 interest? So they told us $3,500 is our interest rate, or our interest that we earn. So that's the I. They told us the principal was $3,500. Now the simple interest, they told us it was 4%, but again, we need it as a decimal. So if I'm going to write it as a decimal, I have to move the decimal 2 places over to the left. So 0.04 is our rate, but we don't know time. That's what we're solving for. We're solving for t. So we have this here. So I plugged in I, P, and R, and we're solving for t. Now again, kind of like we did before, not create a pen, magic pen. This right here, we can simplify the right-hand side. So we can do 3,500 times 0.4. So the 350 won't change. I can grab my calculator, pull it back out, and do 3,500, because that was our starting amount, and multiply it by 0.04. And 3,500 multiplied by 0.04 is 140t. And lastly, to get time by itself, we're going to divide both sides by 140. Because 140 and 140 will cancel, leaving us t by itself. And then we could do 350 divided by 140, and we get t as 2.5. And again, we're talking about 2.5 years, or 2 years and 6 months is how long it'll take at 4% to earn $350 in interest. And that's all we have to do for this problem. So we're just kind of plugging the numbers in and solving for what we don't know. How much money must you deposit in a simple interest account? So this is the same thing as we just did. It's not real different. So here we're wanting to know how much principal do I need to earn $500 in interest. So I don't know the principal, but the interest is 0.04. It's kind of the same one that we did on the last one, in 5 years. So we just have 5, because again, time is in years. Now the next step would be to simplify the right-hand side. So we can do 0.04 times 5. And if you type that into a calculator, you will get 0.2. 0.04 times 5. I'll double check it in a calculator. 0.04 times 5 is 0.2. Then our last step to get p by itself is going to be to divide both sides by 0.2, because 0.2 and 0.2 will cancel. And we should get that 500 divided by 0.2 would be $2,500. So $2,500 would be our amount. And that's it. So now we're going to move on to rate times time equals distance, our distance where we're talking about rate, time, and distance. So d equals RT. So if I want to solve this for my rate, well, I have rate times time. So to simplify it, I'm going to divide both sides by t, because I'm trying to get r by itself, because t divided by t will simplify. So my rate is equal to distance times time. Well, I could have solved it for time. So if I want to solve it for time, I wouldn't divide by the time, I would divide by the rate, because those would cancel, and I would know that time is equal to the distance divided by the rate. So I could solve it for either one and get something similar. I know I jumped through that real quick because there wasn't a whole lot to it. So let's look at some problems here. A truck driver drives an average, or a truck driver averages 60 miles per hour while driving freight and 45 miles per hour on the return trip. So when he's going there, he's averaging 60 miles per hour. On the return trip, coming back, so 60. On the return trip, he averages 45. The total time, so the total driving time is 7 hours. How long does each trip take? So how long does each trip take? So the total time is 7 hours. So the total time is 7 hours. We were going at 60 miles per hour to get there and 45 miles back. So this is our rate. Now the time to get there, I'm just going to call it X. I'm going to say it took X hours to get there. Now the rate going back is 45 miles. Now the time it took to get back, well, we had how much total? We had 7 hours total, yes? So we'd subtract from it the time it took to come back. So this is a little bit weird setup. So what we're saying is the rate is 60 miles, time it takes is X to get there. Well, how many hours do we have total? 7, so however many hours it took to get there, it's going to take that many less than 7 to get back. So our distance here is equal to 60 times X. And to come back, so our distance coming back is 45 times 7 minus X. Now, did it tell us the distance? No, a driver goes to deliver it and comes back. So the return trip. So what they're saying is that the distance, they didn't directly say it, but the distance is the same for both of these here. So what we can do is we can set them equal to each other. $60 is equal to 45 times 7 minus X. Now what we'll do first is we'll distribute, because again, what we're doing is we're going to solve for the time it takes to get there, and from there we can solve for the return trip. So we can use it to solve the return trip. So we do 45 times 7, and we can plug that in a calculator if we need to. 45 times 7 is 315. Minus 45x. Now at this point here, we can add 45 x to both sides, because if we add 45x to both sides, we'll get x by itself. So I'm going to add 45x over here. These here will cancel. And I get 315 on one side, and on the other side I get 105x. And last but not least, we need to get x by itself, so we're going to divide both sides by 105. Those two will cancel out, leaving me with x by itself. And at this point here, we can type in 315 divided by 105. And we find out the value of x is 3. So we solved for the value of x, and we got that it's 3. So that means for us that the time it took to get to the destination when he's driving 60 miles an hour, it took 3 hours. Now to find the time it took to come back, well, we could do 7 minus 3, and 7 minus 3 would give us 4 hours. So 3 hours to get there and 4 hours to come back. So this one was a little bit more challenging than some, and probably some that you'll do on the assignment. So this one here is a little bit harder because we had to solve for time. We had to do that little trick with time. Okay, so let's look at this one here. So another distance equals rate times time problem. A truck driver drives an average 60 miles per hour while driving freight to a customer. On a return trip, the driver drives 50 miles per hour due to construction. The total driving time is 6.6 hours. How long does each drive take? So again, this is kind of the exact same one as the last one. I'm not going to worry about this. So we're going to kind of move on to this one here. So this one here is a little bit different. Dan drove 330 miles at 60 miles per hour. Ryan drove 275 miles at 55 miles per hour. How much more time did Dan drive than Ryan? So earlier in this lesson, we saw that time is equal to distance divided by rate. So if I want to know, say, Ryan, let's do Ryan first. So Ryan's distance was 275, and his rate was 55 miles per hour. So what I can do in a calculator, so I can calculate this, 275 divided by 55. And I get 5 hours. Okay, that's not bad. How about Dan? So Dan drove 330 miles at 60 miles an hour. So again, we can do 330 divided by 60, and we get 5.5 hours. So how much more time did Dan drive than Ryan? 0.5 hours or 30 minutes. Grouping under. So how much more time did he drive? He drove 0.5 hours more. He drove half an hour longer. And that's it. And that's all we're going to do for this year. So you can go on and start working on chapter 1.72's homework assignment, and it'll be in Big Ideas Math. And if you have any questions, I can go over it when I get back with you, and we can kind of refresh and go through this, because some of the stuff is tricky, especially what we did in 1.7, and I can kind of help you with that.